Do you know if what this like thing is referring to?
I have no idea. Yeah,
Jamie, do you
I'm
have any
so
idea?
confused.
I might have something in my down. Let me check.
I mean, I can find it, but I just this is one of these obscure question.
All right, I'm just checking real quick. Isn't that the determinant? Or
It would be if
determinant?
it would be if it had 4 elements. Like
Oh.
usually you need 4 elements. It's odd because it's X and X. It's like it's saying, I mean, this is my first guess here. It's like it's saying that, comma, -3x equals 29. But I really don't know. Also because the answer spaces don't, it doesn't say anything about like, because this one's not a nice number over here. I mean, this one's obviously 10. What we could ask Niko to do if he's willing is to try, because 10 will be larger than whatever this is. So
Okay.
you could also put 10 into both. I don't know, how many guesses do you get on these things?
Good amount. I think like 6.
Okay, if you're willing to use one, you can try it on both.
That's fine.
It'll maybe help.
It's wrong. Yeah.
That makes sense. I have no idea what this is.
No.
It's +1. Okay, well, wait. Okay, there's a formatting issue. That's what it is. So you were right, Jamie. This is what it's supposed to look like.
Oh, that makes
There
sense.
it is. And now it's the determinant. So it's the determinant. This thing means determinant in this notation, these vertical bars. And so this means determinant. So that is x plus 1 times x diagonally multiply minus -3 times 9 equals 29.
Hmm.
Does that make
It's
sense?
just like a formatting issue. It wasn't
Yeah.
just like a weird problem.
Yes.
Okay.
I mean,
Awesome.
if I hadn't seen too many WebAssigns in my time, I wouldn't have known that. And so that's x squared plus x, okay, plus 27 equals 29. You move the 29 over, you get x squared plus x minus 2 equals 0. You factor. Okay, so you get x plus 2, x minus 1, and your two answers are -2 and 1.
Hmm.
Yep, that's perfect. Thank you.
Yeah.
Got it.
Now, just briefly, this is determinant, but if you see this kind of the parentheses, or if it were me in the classroom, I would use brackets because I think it's even more clear. These are the actual matrix. And this is an operator, meaning you have to do something. So it implies like you could have these lines on the outside, but then it's kind of redundant to operate on it. So that's why you're supposed to know that the vertical lines mean determinant. You're like that it's an operator. And just, you guys are taking more math than most students. Like there's more operators than plus, minus, multiply, and divide. This is just another one. The determinant's another operator. Okay. So let's go to the next one here. Use a determinant to find the area with the given vertices. All right, so this is a specific formula, which I need to look up because it's never used except in this context. That's not what we want. Okay. How do they want you to do this? Did you guys get any formulas in class?
Let me check.
I mean, I can
I
just
don't think
do,
so.
we can just do this, but it's, you know, if you were to graph this thing, right, there's, you know, just pick a generic origin there. So -3, 1 is there.
I have.
4, 1 is there. And then 6 - 5 is there, I think. 1, 2, 3, 4, 5. So it's, you know, roughly this shape.
We did get a formula in class.
May I know what it is? So I don't, because I've got another one here.
So it's like a determinant thing, 1/2.
Yep.
It's x1, y1 in the first two columns, and then 1 in the third.
Like that.
Y2, yeah, like that.
Okay. And then what do you got next?
X2, y2, and then 1 again.
Okay.
3y3, and then 1.
Like this.
You do the determinant of that, and it's
Yeah.
1.
Okay, right. So like this is x1 and y1, this is x2 and y2, and this is x3 and y3. You guys have your calculators today?
Yeah.
And are you allowed to, I assume you're allowed to use that?
Yeah.
So we want to make a 3x3 calculator matrix. And I'll get mine out and snip to that screen. All right, so I'm gonna share my calculator screen. And you know, if you guys are already ahead of me, just let me get caught up here. So second matrix, and we want to go over and edit it. So go over to the right, edit, boom, 3x3. Okay, and then just putting those values in. So -3, syntax. Annoying. Okay. -3. Oh, 2 negatives. 3. Enter. 4. Sorry, that's 1. Okay, and then if you're already ahead of me, the command for determinant is under matrix math, but you have to do the determinant first, and you can divide it by 2 or do the 1/2 out in front. Get cut up here. 4, enter, 1, enter, 1, and then 6 - 5, 1, enter. All right, quit out. Second matrix, math, determinant's the first one. You got to go grab that matrix, second matrix again, go grab it, enter, close parentheses. Don't put the divide by 2 before you close parentheses because that'll do something else. And you should get -21. So since it's positive, hopefully that works. That was yours, Niko?
Yes.
Is that correct? Does that work?
Let me check right now.
Thank you.
That's wrong. -21, right? Yeah, that's.
It's got to make it positive.
Oh, sorry. 21, and then. Yeah, that's right. Perfect.
Okay. Like this number, this is not quite right, but they're just picking an arbitrary point in the third dimension, but you can always use 1. So you got to know this formula to do this one. Is that okay? Is that clear?
Yeah. Thank you.
All right. Okay, so we're back to Jamie. And this one's definitely a calculator problem here. Let me get. Did you find the inverse of A in your calculator?
The inverse of A?
Yeah, like that's just a straight calculator value. Let me go back and share my screen. I'll get that question in. So 7, part A. I'm snipping into my screen now. Part A is just going into your calculator and getting the inverse of that.
I have it.
Okay, what's the inverse?
2, -1.
I'm sorry, go top left again.
2,
2.
-1.
Okay,
-3.
all right. I missed one. Where am I wrong?
2, right there.
Down there. Yeah, okay. All right, just making sure. So part B looks difficult, but what I'm seeing here, let me just get this picture, is it's related to these numbers on here. It's related to these numbers up there. It's essentially it's the transpose of that matrix.
Okay.
And let me try to show you that here. So 85 and 50 are there. 6 and well, no, I'm sorry, it's not.
Oh, do you just keep writing it out a
I
lot?
guess, yeah, I guess this is like 10 and 5.
Okay.
This is not like a standard thing. So 42. Sometimes you can try just a couple of elements. So let's keep going here. I have to look at that other screen. This is annoying right there. Okay. 90 and 55, 60 and 40, 30 and 15, 19 and 12. So will you check that for us before we go further?
Yeah. Yeah, that's right.
Okay, so we're going to call this matrix E. Okay, E is size 9 by 2. 9 rows, it's always row by column. Okay.
Huh.
Step 3 says to multiply the encrypted matrix
Oh, by the
by
inverse
the
one?
inverse. So the inverse is 2 by 2. You're going to multiply it by 2, -1, -3, 2. So you're going to want to put this into your calculator. This one on the left here. And then you've got the inverse there. So what I'm going to do is let you guys do that if you want. I'm going to go not do it on the calculator because it's too slow and I'll make some mistakes. I'm going to do it in another way and get back to you with my answer so that you can have that as well if you need it. And Niko, if you need different numbers, if you want to send them over, it's up to you. Definitely work through that.
I think I got it. I'm just following along what you guys are doing. Just changing
Excellent.
with my numbers. Yeah.
Excellent. So this is a good example of when you enter this matrix E and you definitely want to print it out on your screen and make sure it's what you expect it to be. Otherwise, you can really run into some issues. With whether you did this right or not.
Mhm.
So as I said before, like what I do before I do any calculations is I snip it in, and I would even just compare, to what I think is supposed to be there. That way, you don't go any further. This is, they call this in programming echoing, or doing something that, just to see that like is what I think is there actually there. And then I'll let the calculator actually do the rest of the calculations. So I gotta do the inverse. All right, no, that didn't, where is that? Okay, so here is my answer. Snip that in. So this is the E, this is the answer to E times A inverse. And that should match your output on your calculator. It's designed to give you nice numbers. So Niko, if you don't have nice numbers on yours, then you know, just check your.
Okay. Yeah.
Okay, and then we can do the next step here of decrypting it whenever you're ready for that. If you can, if you think you got this.
Yeah, should be good.
Okay, so the next thing it says you need you need to know what letters go with what numbers. So the very first cipher, I'm going to go off into a little bit of story time here, was called a Caesar cipher, and literally Caesar would send messages and he would just give a transposition number. So instead of A being 1, it would be like 5 plus 4, B was 6, and so on. And it's a pretty simple cipher, but you have to, these guys that would do these would become more elegant in the way they would do this, lots more manipulation, but essentially it all gets back to like mapping numbers to letters. So in this case, T is 20. So it's T is 20, 15 is O, and then the 0 is a space. 2 is 5. I'm sorry, is B. 5 is E, 2B. And then we'll do another space here.
Oh no, it's gonna be or not to be.
Yeah. Okay, great. Don't put the underscores, put those as spaces in your
Yep, that's right.
yeah. So you guys ever go to the ATM, get money or make a transaction at, like, go to a store and buy something and put your debit card in?
I've not.
Usually no.
You never done that?
Mm.
Go ahead.
I've seen my parents do it, but I've never
Yeah.
done it myself.
Okay, all right. So there's public keys and there's private keys.
Mhm.
So when your pin on your debit card is like a private key. Okay, like, you know that, that's why it's private. Public keys are when you go to a merchant, they have to like authenticate with the bank here, and they use both a public and a private key to do this. And so like they encrypt these gigantic numbers into prime factors. So they'll encrypt a like a 24-digit number into prime factors, and there's algorithms to do this. And that's how these two, you know, Target and Chase, you know, let's say you went to Target or wherever, Starbucks, that's how they know, like, oh, like that's online, that's good. But they also use your private key, your PIN, through the merchant to make sure that, because your bank knows your PIN independently, that it's actually you. So they use these things in tandem, and there's both public and private keys, but they're all encrypted using ciphers. And they don't use Caesar ciphers. They don't even use these. These are called Hill ciphers, what you just did in this problem. They're just, they don't use any of that, but because they're too basic, they could be cracked. But if you're interested in that stuff, the NSA, National Security Agency, they do lots of stuff like that and more. But you may find that interesting. So, what else would you guys like to work on today?
I'm looking at our website and see if there's any more questions.
Yeah, we got a really short one this time for the most part.
Okay, any interest in doing a question of the week? It's up to you guys, of course.
Sure.
Yeah, sure.
See if
Do
this
it.
one's any. See if this one's any good. Oh yeah. All right. Have you guys signed up for the SAT ACT yet, or how's is that at all of interest?
Not yet.
Sure.
We just did a PSAT.
Yeah, we did the
That's what I
PSA.
did this year.
All right. So the questions I write for you guys and just for in general, like they're often harder and more emphasis on story problems because that's what most students struggle with. You guys have done great on these, so I hope you'll see some success on the exam there. So, all right, let me read this together, and then I'll see if you guys. This is not a calculator problem, but you're welcome to use one. It's I think there's some multiplication here. So at the end of fall, an outdoor farmer's market sells lemons, $4.40 per kilogram. An indoors farmer's market pickles are sold for $3.40 per kilogram. To gain access to the outdoor market, a shopper must pay a fee of $11. To gain access to the indoor market, a shopper must pay $7. If a shopper spends $28.60 at the outdoor market and spends $17.20 at the indoor market, how many total kilograms in fruits and vegetables did they buy? So I'll give you guys a couple minutes here to just think through it. And then I can work through the solution if needed. And if you can, chat me your answer, but take a few minutes. See if this one's intentionally unclear. So just keep that in mind as well. Niko, how are you doing on this one?
Good, almost done.
All
Just
right.
wrapping stuff.
Yeah,
stuff.
Jamie's already sent over his answers, so
Oh, shoot.
take your
I'll
time.
do it right now.
He's on a hot streak right now. So all right. So Niko, your answer is correct, but we should be getting an exact answer there. So Jamie, you did this really quickly. What about this was easy, or what made sense to you? What was so clear about doing it?
I just saw like quickly that the fee to get in was a really big part of it, and that
Yep.
it was additional price. So I knew that the total was the amount of kilos plus the fee to get in. So I just did the math real quick and got the answer.
Did you use a calculator or do it by hand?
I used a calculator for this.
Okay, no problem. Yeah. So this is one of those problems, one of those like techniques where if you don't write stuff out, you save time. Like if you realize, okay, to go to the outdoor market, I'm spending $28.60 and it costs me $11 to get in. I subtract the two. That's $17.60. And at the outdoor market, I'm buying $4.4 per kilogram of something X. Okay. And then you do the same thing for the other one. 1720 subtract 7, that's 1020 equals 3.4x. Okay. Now these look like they're hard to do without a calculator, but they actually work out really nicely. And that's why I said you can do these without a calculator. That's why it's 4 plus 3, which is 7. Okay, so if you believe me that you can do it without a calculator, which I hope you do you believe me?
Yeah.
Yes.
Let me give you one more here, and I'm going to just ask. You can do whatever you want. Not do it with a calculator, and let's see if you can do it in under 60 seconds. Like you know how to do it. There's no reason not to. Are you guys ready for me to snip this in?
Yes.
All right. Timer is going now. All right, got Jamie again in the lead, and Niko also in the lead. Good there, great. You guys did that really fast. So, these are the kinds of questions that you should definitely be able to tackle and do. Is there anything else you guys would like to work on today?
I think it's good.
Jamie, it's okay if you need to take a minute or two and look.
Yeah, I'll just make sure, but I think that's everything.
Niko, when's your next exam?
I think it's sometime next week. I'm not sure if she gave us the date yet.
Okay. All right. Nico, you're welcome to jump out if you want. Jamie, I'll stand by and see if there's something else you want to work on.
Okay, awesome. Thank you.
Yeah, have a great night. See you next time.
You too. Thank you.
Yeah, I think that's everything. Just looking through all my stuff right now.
Yeah, you're always welcome. If you want the time, I mean, if you need extra time with something yourself here, let me know.
Okay. Should be good. Thank you.
Great. I'll send you the notes out shortly. Thanks so much. And I'll see you next time.
Thank you.
Have a great night. Bye now.
You too.